Question 15. The following list midterm and final exam grades for a sample of students in English 101. Part A, create a scatter plot of the data. Well, in order to do that, I need to scale two sets of axes, one that's horizontal for the midterm grades because that's labeled X, and one that's vertical for the final grades because that's labeled with a Y. The midterms, it looks like the lowest is a 50, the highest is 93, so I think I'll just go, I'll go from 40 to 100 by tens, and that should be reasonable so I can fit all the data. Okay, so 40 all the way up to 100 by 10, so that's good. The finals, the low here is 70, the high is a 97, so I think I'll just go 60 to 100 this time. But also by tens. Okay, so that's set up. Now I just need to put a point in for each pair of midterm and final exam grades. So my first pair is 82 and 94. So I find 82 for my midterms, then go up to 94 for finals, put a point in. 65 and 77, so 65 is about right here in the midterms, 77 for the finals, about right there. 93 and 94, so about right here and about right there, that's fine. 70 and 79, this looks pretty good right there. 85 and 95, right there. 50 and 70, that looks good. 95 and 97, 80 and 91. Okay, there's my scatter plot. Alright, part B, find the correlation coefficient R, round to 3 decimals. So what I need to do is just start putting the data into L1 and L2, and then run the linear regression function. Okay, so I go under Stat, Edit. I've already got some data in here, so I highlight the name, press Clear and Enter, and that'll erase it. And I just start entering the data. All of the X data goes into L1, all of the Y data into L2. And remember, like these two pieces of data are, combined. They're one data point really. So I have to have that 94 directly across from the 82, so I can't, so don't go through and try and sort these data sets or anything like that. Don't mix them up. So I'll go ahead and punch it in and then restart the video. Okay, so got all the data in. Now what I want to do is run the linear regression function in the calculator. So if I hit Stat, slide over here to Calc, linreg is the fourth option. Just press Enter twice, and the last number that comes up here is R, and so that value 0.960 is what we're looking for. So that's the answer to part B. R equals 0.960. Alright, if you didn't see these come up, R squared and R, that means in your calculator you don't have diagnostic onset. But what you do, hit second in catalog and scroll down until you get to a function called diagnostic on, and there it is. Press Enter twice, it'll just say done. But this time when you go through the linear regression, you'll get the R squared and R. And that's set until you reset your calculator or take the batteries out or whatever. Okay, now part C. Part C says to write the equation of the regression line in the form y equals mx plus b and to round to 2 decimals. Well, to do this, you've got the output of the linear regression. The value A is given as 0.65 if we round to 2 decimals. And the value of B is given as 36.81. So that's what we're going to write for our line here. It's going to be y equals 0.65x plus 36.81. And that's our line of regression. So not only does the output screen here give you the correlation coefficient, it also gives you the line of regression as well. Part D, if a student makes a 76 on the midterm, predict their final exam grade, round to 2 decimals. Well, the idea of this line, the line of regression, if I graphed this line on these data points, it would be a line that pretty well fits those data points. So for instance, it might look like this, perhaps. That seems to fit all of those data points pretty well. And the idea is, using this line, we can make predictions about data points that are not in our original data set, like the 76, for instance. So the 76 is right about here, and this is where it intercepts the line. And then using that point of interception, we can kind of make a prediction as to what the output value would be. So it looks about like an 87, but we're not going to use the scatter plot to do this. We're going to use the equation of the line that we just came up with. And the way that we do that is like, okay, so we plug in 76 for x. So 0.65 times 76 plus 36.81. So whatever value we want to predict based off of, we plug into our line equation for x. So come over here to the calculator. I'm just going to hit clear to get rid of all that stuff. 0.65 times 76 plus 36.81, 86.21. So that's our predicted value. So equals 86.21. And it's said to round to 2 decimals, so we'll just leave it as is here.